This lecture is about file I/O. More specifically, I'll show you how to read from a text file and write into a text file. In order to read from a text file, I use Java util scanner class, and I'll show you how to handle the input mismatch exception that can be thrown by some of the methods inside the Java util scanner. Also, I'll talk about Java I/O PrintWriter class and the methods it has that allows us to write into text files. Finally, I'll spend some time on printf method from the PrintWriter class so that you know how to do formatted output into text files. Now imagine you want to read a text file, a file whose name is given by a string. So in that case, you can write this Java method called readFile, which gets a string file name and basically reads the content of the file. In this example, I only read the file content and print it out line by line. I don't do anything special with the file content, but you can do whatever you want. You can process the file content in any way you want, but this method only prints out each line of the file. So the string file name allows me to uniquely identify the file in the file system of the computer that runs this program or this Java method. The first thing I need to do is to create an instance of the file class. I just need to say file, the object file name, let's say infile equals new file, and then I pass the file name as a constructor, as an input parameter of the constructor of the file class. So although we call this a string file name, it can be the path of the file followed by the file name. For example, assuming that you have stored your file in a directory called input, then the file name can be something like this: input slash the file name. Let's say the file name is results.txt. So this can replace the file name that I have here, right? Or if the file result.txt is inside the root directory of your project, then you don't need the input slash part. You don't need to pass the file path along with the file name. You can just have the result.txt. After the file instance or the file object is constructed in this line, it's time to create a scanner. I will say let's create a scanner like scanner in equal to new scanner, and then I pass the file name or the file object, I should say, as the input parameter of the constructor of the scanner. Now the file is open and it allows me to scan the file using this scanner object in. How do I read the file content? This for loop basically goes over every single line of the file and reads each line separately. The first iteration, I is 1, and as long as in that has next line, which is a method that returns true if there is a next line in the file, as long as this returns true, I'm going to print out the next line. So I will say system.out.println the string line followed by I, in the first iteration I is 1, colon, and then in that next line reads the first line in the first iteration of the for loop. The first line that is stored in the file with the given file name. Now, after the first line is printed, we're gonna increase the value of I by 1, and then we're gonna check the scanner again and make sure that we haven't reached to the end of the file, and as long as there is the second line, we are going to do the same thing for the second line. We say print out line followed by I, which is now 2, colon, the next line. You can do this as many times as needed for the file. Let's say if the file has 100 lines, this for loop iterates 100 times. And finally, at the very last iteration, in that has next line returns false, because the cursor that allows me to read the file content will reach to the end of the file. That's when I get out of the file, I close the scanner, and that's it. You don't need to close it, but it is a very important etiquette to follow, because if you don't close the scanner, there's a chance of file data leakage. Also, the file stays open and no other application can read the file, because you cannot simultaneously read a file in a normal situation. So it's a very good etiquette of programming that you close the scanner whenever you finish working with it. One more thing that you need to remember is that the file name may not be valid. And in that case, the file cannot be opened and you cannot create a scanner on it. So it may throw an exception. Let's say a file not found exception, which is an IO exception. So in this case, you have two choices. Either throw the exception like this, so that the caller of read file can take care of it and can catch it, or you can place this code inside the try block, and then right after that you can have a catch clause that catches the IO exception that can be thrown out of this block. Now let me show you a very simple example. Let's say you have a tabular data, basically a table that is stored in the form of a tab delimited text file. What does tab delimited format means? This table of numbers and strings can be stored in a text file in the following way. In each row we have multiple cells. Let's say in the first row you have 10, 20, 3.4, 50. These cells are separated by a tab. So there's a tab between 10 and 20. There's a tab between 20 and 3.4. There's a tab between 3.4 and 50. And after the last cell, we have a new line so that each row is stored in a separate line. The next row is stored in the next line, and again between 11 and 22 you have a tab. Between 22 and ABC you have a tab, so on and so forth. And again at the end of the second row we have a new line, and finally the last row is written here, and then after that we have no other character but an end of file. End of file is a special character that ends the file. So this is called the tab delimited format. Normally the extension of this type of file is .txt. If you create a file, a text file with this content, you can open it with an Excel program, a Microsoft Excel program. So all you need to do is use a text editor to create a file like this, call it whatever you want, but the extension should be txt, and then open the file with a Microsoft Excel program, and it opens the content for you in the form of a table that you see in the screen. Now, what I'm going to tell you is uh, let's find out how we can read this file and its content using a scanner. What I want to do in this example is I only want to read the integers. I'm not going to read any double value or any string value. I just want to read integers only. Uh, I consider non-integers faulty input, and I'm gonna ignore them. I will replace them with a 0. And in order to acknowledge that I have received those integers, I'm going to print them on the output. So let's see how we can make this happen in this method. The method name is called echo integral data. That gets a string file name. That's the same file that contains this tab delimited table. And I will say this one throws an IO exception because the file name may not exist. Then I open the file and create a scanner similar to the previous slide that I showed you. Then I will have a while loop, and I say as long as there is next element, while in that has next. I don't say next line because I'm interested in reading every single cell, not every row. So while in that has next, first I define a temporary variable called value with type int, initialize it to 0, and I try calling the next int method of the scanner on the object in. If there is an integer in the next cell, then I will read the value, and the value will be equal to the value of the cell that I'm reading next. However, if the value is not integer, if it's double or if it is a general string, then this next int is going to throw an exception. The exception type is input mismatch exception. And then I will catch it in this clause, and I will skip the faulty input because I assume any non-integer is faulty. So I will basically say in that next to just skip this current cell by jumping over it using in that next. Next basically moves the cursor one word forward, and I basically skip the faulty input, the non-integer input, and then, or I should say, I will skip the non-integer cell. And then after that, I have a finally clause that regardless of whether I have an integer or a non-integer in the next cell, it's going to print out the value. If there was an integer in the current cell, then value will be the value that you see in the cell. Otherwise, if it's a non-integer like double or a string, then you're going to see 0. And then finally, after the while loop ends, I'm going to close the scanner. So I'm just going to show you what the output of this code looks like if you run it on a file. Let's say the file is called table.txt. So let's say you have created this table.txt file, you have stored it in the root of your project, and then you have passed table.txt to the method echo integral data. What's going to happen? What will be the output? The answer is this. This line in the first cell, which is 10, prints 10. The next call to system out println will print the next cell, which is 20. Next, it prints 0, not 3.4. Why does it print 0, not 3.4? Because 3.4 is not an integer, so the next int will throw an input mismatch exception, and I will skip the 3.4 using the int.next, and in the finally clause I will print 0. Why? Because value is initialized to be 0. Then I will print 50, and then after 50 I will print 11. So after the first line ends, I will begin the next line. This next method this next method or next int method will read the next cell, and it doesn't care whether the two consecutive cells are separated by tab or by new lines. For example, the two consecutive tabs, the two consecutive cells 10 and 20 are separated by a tab, but the two consecutive cells 50 and 11 are separated by a new line. But it doesn't really care about that. It just prints 11 after 50. Then it prints 22. Then it prints 0 because ABC is not an integer. Then it prints the integer representation of this. This is 100 million. Then it prints 0. Then it prints why 0? Because 4.5 is not 0. This one is a little bit tricky. I need to count how many zeros we have. So we have 3, 6, 9, and this is basically 21 billion. This is too long. This is a long, not an integer. So with this, we will see the exception, and the exception will skip this cell, and the output will be 0 for this cell because it's not an integer, it's a long integer. The next one is negative 12, and the last one is 222. So you will see the negative 12 and 222 on the console on the two final lines. Now I'm going to show you a very similar example. This time I'm going to determine the type of every cell in this table. So now I'm not interested in reading the integers and skipping non-integers. Now I want to do the following. I want to figure out the type of the data in every cell. So in other words, I want to basically recognize the type of this one, which is an integer. Then I want to recognize the type of this one, which is an integer. This one is a double. I want my Java program to specify that this is a double. For example, this is a string, so on and so forth. So this is what I will do. I will have this first two lines that allows me to construct a new scanner on the file whose name is given as an input parameter of the method determine type. Then after the scanner object in is constructed, then I have a while loop. As long as the scanner has the next word, then I will try calling the next int method on the in object. If there is an integer in the current cell, then I will read the value, and the value will be ival, and I will print out int colon space followed by the ival. For example, for the first cell, you should see something like this. You will see int colon space 10, and then there's a new line because SOUT stands for system.out.println. Now let's say the next one would be another integer, so it's going to be int colon 20 this time, new line. But after that we have 3.4. 3.4 is not an integer, so this next int will throw an exception, and this exception that is thrown will be caught by this clause because it catches any input mismatch exceptions. So in this catch clause, I will try again. I will write a try block again, and inside the try block I will call the next double. Fortunately 3.4 is a double, so this is not going to throw any other exception, and I will print double space, double colon space, and then the dval, which is the value of 3.4. So most likely you should see such a thing, double colon 3.4 and then a new line. And then after that, for example, 50 is an integer, 11 is an integer, 22 is an integer. So you will see the same pattern. You will see int colon 50, int colon 11, int colon 22. But when we reach to this one, which is ABC, ABC is neither int nor double. So this will throw, the next double will throw another exception as well. And I will catch it in the second catch clause, which is a nested catch inside the first catch. And in this clause, I will print out a string colon space, and then I will call in that next. And that's pretty much what happens with the ABC. So for the ABC, you will see a string colon space, and then you will see the ABC. So what I want you to do is I want you to, as a test, just construct a Java project, create a main method, and in the main method, call this method after passing a file name like, for example, table.txt. Then you create a text file with a text editor and store the content of this table in it. As I said, make a tab delimited format, which means between every two cells in a same row have a tab, and then between two consecutive rows add a new line, and then after you save it, try running this and see the output for yourself. Now let's see how to write into a text file. So far we have seen examples of reading from a text file, but if you want to write into a text file, you cannot use a scanner anymore. You need to use another class. The class that is used more often for text files in Java is Java IO PrintWriter. And it's a very easy class to deal with. If you want to use this constructor, you need to pass the file name to the constructor of the PrintWriter. And when I say file name, I mean file name and possibly the path of the file. And then you can simply use the print method to write text into the file if you want to just write a single word. If you want to write a whole sentence or a whole line, I should say, you can use println method inside the PrintWriter, and that will print out a whole line followed by a new line in the text file that you're writing into. Also, if you want the formatted print operation, then you can use the printf method of PrintWriter, and this will write the text in a specific format. As you may know, I'm sure you have used system.out.printf. The first parameter is the format, and inside the format you can have different placeholders like %d for integers, %c for characters, %s for strings, and each placeholder can have a width option and can have a precision option and can have some extra options that I will briefly show you next. Also, the print statement, the print method or the print operation of the PrintWriter sometimes is lazy, which means it does not reflect the changes on the file immediately. If you really care about reflecting the changes on the file immediately, you need to use flush method right after printing something. This way you are 100% sure that the PrintWriter eagerly writes into the file instead of waiting and writing into a file later after accumulating multiple lines of data. Also, similar to scanner, you must close the PrintWriter if you want to basically save the changes and close the file that you're writing into. Now, let me show you an example of how to write into a file. I have created this method. This is method this is a method that allows you to either open an existing file or create a new file and write some data into the file. The write file method gets a string file name and an array of strings. We call that data, and then it will construct a PrintWriter object by passing the file name to the constructor of the PrintWriter. Then for every string line inside data, we're gonna use println to print or to write one of the elements of the data array into the file with name file name, and at the end of this for loop, we're gonna flush all the data that we have written into the file and make sure that all the data that we have sent to the file using println will be stored in the file, and then finally we close the file using out.close, or the close method of the PrintWriter. Out is just an object of PrintWriter class. Please note that the PrintWriter constructor can throw an exception if, for example, the file name is not letting you to write into it, or for example, if the file name is made of some illegal path that the file system doesn't recognize, then the constructor can throw an IO exception, like a file not found exception. So you gotta either put this constructor inside a try block and catch the exception in the same method, or like the way I did, you can throw the exception from this method so that the caller of this method can take care of it by either catching it or throwing it as well. I know that you probably are familiar with printf when you use system.out.printf, but I'm just gonna briefly explain it one more time for those who have forgotten how printf works. Basically, printf, either the printf that you use in system.out or this one that is inside the class PrintWriter, gets a string format as its first parameter, and this format can specify multiple placeholders. Each placeholder is specified by a %sign, and based on how many placeholders are inside the format, you may have multiple, or a number of, I should say, arguments after the first parameter. I'm going to show you an example. Let's say you're calling printf on an object of PrintWriter that is constructed this way to write into a file called out.txt, and the first parameter is %d space %f space %c space %s space %e, and because there are 5 placeholders here, I need to pass 5 extra parameters to the printf. The first one, which is -1, 2, 3, will replace the %d because it's an integer, so %d accepts the type int parameter. So %d is replaced by -1 to 3. So you're going to see -1 to 3 on the out.txt file. Then we're going to see the %f, which is 2.3.0. So this double value will be printed instead of this printf. So we'll replace this printf, this placeholder, I should say, which is %f. The value should be 0.666666666, maybe like 15 sixes and a 7 at the end, because that's the value of 2/3. Then you're going to see a space and a %C, which should be replaced by letter B, and then a space and a string that replaces this %S. The string should be hello, and finally a space, and then this %E will be replaced by the normalized scientific notation of this number, which is 3.2 E plus, I'm sorry, E minus 1, 2, 3, 4, 5, 6. If I'm not mistaken, 1, 2, 3, 4, 5. Yeah, that's right. So it's going to be 3.2 E negative 6. That's the normalized scientific notation of this double value. It's good to use %E instead of %F when your double value is either too small like this or too large, so that it would be more convenient to use a normalized scientific notation. There are some other placeholders like %G, which is replaced by a floating point number in scientific notation if the number is very large or very small, and it's going to be same as %F if the number is not too small or it's not too large. We call %G a general floating point. So these are the most commonly used placeholders inside the format parameter of the printf method. You can customize the flags, the placeholders like %D, %F, %E using multiple flags like minus, 0, plus, open parentheses, comma, and this caret sign. Also, you can customize them by adding a width and precision option. For example, if I say %-4D, the 4 is the width option, and basically means this placeholder should be replaced by an integer that has at least 4 characters. If you don't have enough characters, then it's going to pad your number with extra leading spaces. For example, if you want to print, for example, 5 using %4D, we're going to have 3 spaces before the number, because you have a 1-digit number and you want the width should to be at least 4 digits or 4 characters. So you need to add some leading spaces. Because of this minus sign, the spaces should be to the right. That means the spaces should be trailing spaces, because the flag minus will print the value in a left aligned fashion. For example, if you print 12 with this placeholder, then the outputs would be 1, 2, space, space. Why do we need 2 spaces? Because the length is 2 and the minimum width should be 4, so you need 2 extra spaces. Why do you put it after the 12? Because of this minus. If there was no minus, then it would print it this way, spaces, space, 1, 2. Then we have a similar situation for, let's say, the %F. For %F, I can customize it using both width option, which is 7, and precision option, which is 2 here. And also I can use minus, that means I want the left alignment, and I can use plus, that means I want the sign to be explicit. For example, if you have a value like 1.16 and you want to represent this using, or you want to print this using this placeholder, % plus minus 7.2f, then the output should look like this. It's going to be plus, well, let's add another character, another digits to this. So let's say the number is 1.167, for example. So the output would be a string like this. the output would be plus, you're going to have 1.17. You may say, why did you convert 6 to 7? Because we need to have 2 digits of precision, and I have 3 digits here, so I need to round it to the closest 2-digit number, which is going to be 17. Because the third digit is 7, you need to round it up. If it was 5, 6, 8, and 9, you still have to round it up. But if the third digit was 0, 1, 2, 3, 4, then you need to round it down. Anyway, so let's see how many characters we have. Plus is 1, 1 is 2, dot is 3, 1 is the fourth one, 7 is the fifth one, and I need 2 more to get to the minimum width that I need, which is 7, right? And because of this minus, I need to add 2 extra spaces after the number. So this is the string that will be printed out if you try printing this number 1.167 using this placeholder percent plus minus 7.2f. And finally, let me show you something about percent %s. Let's say you want to print hello world. Well, that's not a good idea. Let's say the string is greetings. And you want to print this string using percent %5.2s. So what I need to do is I need to take care of the precision option and width option. Precision option basically will truncate the string and it only keeps the first 2 characters. So I will only have GR from greeting. And then the 5, which is the width option, will basically pad the string with 3 spaces in the front so that the total length becomes 5. So this is the result of printing greeting using percent %5.2s. So the precision option in percent %s is not really for precision, it's only for truncating your string.